Okay, 11.1, Systems of Linear Equations, Solutions by Graphing. Let's see what a system is. A system of linear equations is when we have two or more linear equations working together. Remember, just a linear equation is something that's going to be in the form of, say, you could have y equals mx plus b. You can also have it in standard form of ax plus bx equals c, which, to be honest, is going to be the preferred method a lot in how we do some of this, but you'll see both examples. So here is a system of linear equations right here, and what we're made to do is to show that 2, 1 is a solution to the system. So we have an x value and we have a y value, and what we're going to do is we're going to take x and replace it into each equation, solve the equation, and see if we get the answer prescribed. So let's try the first equation here. Okay. First, we're going to put the 2 in right here for the x, minus 2, and then we're going to take the 1 and put it here. Does that equal 0? Well, 2 minus 2 is going to equal 0, so that one checks out. Now let's do the second one. Second, we're going to do the exact same thing. We're going to take the 3 where it has x, we're going to substitute 2, plus where it has the y, we're going to substitute 1, and it all should equal 7. Well, 3 times 2 is 6, plus 1 equals 7, and yes, that does check out. We do have 7 equals 7, just like over here we have 0 equals 0. So yes, that does check out. Pretty straightforward. Let's go to the next page and see another example here. Okay, now we're going to see one to show that 0, 4 is not, not a solution. Okay, once again, we're going to do the exact same thing. Notice we're in a different form now, which in these cases, it's just fine. Later on, we're going to be kind of one to get things into more standard form. You'll see why later, but we won't. Let's not jump to anything else right now. Just start replacing. We have our x, we have a y. So first equation, with our y, we have a 4. Okay, equals negative 0 plus 4. Okay, well, 4 equals, well, what's negative times 0? Of course, 0 plus 4. 4 equals 4. Okay, that one checks out. Let's do the second one. Same process again. Okay, we're going to have 0 equals 2 times what? We're going to have, I did this wrong. I'm sorry here. That's going to be a 4 there. Okay, 2 times 0 plus 1. Well, 4 equals 2 times 0 is 0 plus 1. 4 equals 1? I don't think so. So this one right here does not check out. So as you can see, they're correct here in what they're saying. Show that 0, 4 is not a solution, and we found out it's not a solution because for this to be a solution, 0, 4 has to be able to be put into either one of these linear equations, and it has to work. So have a little checklist that we can do here to solve a system of linear equations by graphing. Graph both linear equations. We know how to do that because we know, especially when they're in this form, we know that that right there is the y-intercept, which would be for this one right here. Remember, that would be at 0, negative 4. Okay, we have the slope here. Okay, and there we go. Sorry, 0, 4, not just 0, negative 4. My bad. Observe the point of intersection if there is one. We'll see that on, I'll show you on a graph here shortly. If the slope has two lines that are different than the lines intersect at one and only one point, this system has a single solution. You'll see that. Most of these you're going to see a lot more in the Hawks. Check the solution if there is one. Okay. If a system is consistent, it has one or more solutions. So you can see that this one right here, that would have been example 1. If a system is inconsistent, it has no solutions. That would have been example 2. And let's go down here. Okay, solve the system by graphing. Okay, this is the same one. Remember the one that we just did up here, example 2. Okay, we're going to show this one by graphing. Okay, so let's go ahead and graph this real fast. And then you can see why it doesn't work. And then they're going to give us a new intersect point here. But first, let's graph the first part. Let me kind of pull down the equation here. Y minus x plus 4. Y equals negative x plus 4. And y equals 2x plus 1. Okay, let's graph the first one. I'll graph it in, let's graph it in blue. Okay, we're going to go to the intersect of right here because we know that that is our intersect. Now we're going to go down. Remember, this is the slope. Okay, so this slope is basically saying this thing is going to have a negative 1, 1. That is what that is saying. So this is going to go down 1 and then over that way. So we go down 1 and then over, down 1, over, down 1, over, and we can also go the opposite way with it. Okay, now let me see how well I can draw a straight line on here. It's not horrible. Tried to use a ruler, but probably could have done it better, probably freehand. Okay, now let's look at the other one. We have another equation here. We'll do this one in purple. We have 2x plus 1. Okay, so we're going to go up here to the 1. And then here, our slope is 2, 1, which is going to go up 2 over 1. So 1, 2 over 1. If you'll notice here, if I had drew this better, sorry for my horrible English, the point would have gone straight through and they would have met right here. So you want to try to draw these as accurate as possible. So this right here is 0, 4. Let me pull this up in red. Is 0, 4. Remember, in our example 2, 0, 4 was a solution for this equation right here. But it was not a solution for this equation right here. But when we start noticing that this right here is a 1, 1, 2, 3, this is the point 1, 3. So this right here, this point where they intersect, just like we saw up here, if the points of the two lines are different, then the lines intersect at 1 and only 1 point. The system has a single point as its solution. That is what we're seeing right here. And we can plug these in. We'll do that very quickly. So we have, oops, don't know what I just did there. So we have y, but instead of y, we have the points 1, 3. We have our x, y. So we have 3 equals negative 1 plus 4. Well, negative 1 plus 4 is going to equal 3 equals 3. That solves this one. Well, how about 3 equals 2 multiplied by 1 plus 1? Well, 2 times 1 is 2 plus 1, and you're going to get 3 equals 3 there. Now, this point here solves both equations. So, we'll do more questions in Hogs.